Okay, so this is just a couple of examples that are similar to the review sheet that you guys should be doing. Okay, in part one, I'm just asking you to expand. So remember, if you're expanding this, one logarithm becomes multiple logarithms. And multiplication, right, is written as addition. And division is turned into subtraction. So you're going to do log base 2 of x plus log base 2 of y squared minus log base 2 of z. All right, you're using the same base all the time, and then the last step you have to do is bring the exponent to the front, and then this is fully expanded. Okay, so every variable or number being either multiplied or divided gets their own operation. Okay, then this is like part two where you're condensing, so multiple logs become one log. So we're going to do exactly the opposite. I'm going to take all the coefficients to the logs, and those are going to become exponents. Okay, so log of x, the base is 10. Remember, we don't see it, but if you don't see a base, it's 10. So log of x squared plus log of y to the 1/2. Remember, 1/2 power really means the square root of y. And then minus log of 3, that doesn't change. Then you're going to change the addition into multiplication and condense all the logs. So all the logs collapse to 1. You have x squared, the square root of y, those get multiplied because you're adding them. And then you divide by 3, okay? So that's like part two. Part three, you can see this is an exponential equation. Hopefully you can recognize this is where you can rewrite the bases using the same base, right? Then, sorry, this should be 4 to the 3rd power. And then you have n plus 3. And then since these have the same bases, you can cancel those two using the 1 for 1 property. 1 base for 1 base, 1 for 1 on either side property. And then 2n equals multiply the 3n plus 9, okay? Make sure you distribute that 3 to the 3 as well, because everything gets multiplied. And then you would just subtract 3n. So then negative n equals 9, so n is negative 9, okay? Part 4, okay, is where you have an exponential equation, okay, but you can't rewrite 64 with a base 19. That would never happen, okay? So what you have to do here is take the log, right, rewrite this in log form. So log base 19 of 64 equals p. Then in your calculator, you're going to do use change of base, right? So this is called change of base formula. And then you're going to do log of 64 over log of 19, sorry, equals p. And then you can put that in your calculator like we did on the homework. Then part 5, right, is where we have a log, a single log. All right, so now we're kind of working with log equations. And it's kind of annoying to work with a log equation. So if there's a single log, what you can do is rewrite it in exponential form, which is the opposite of what we just did here, okay? So now I have 6 to the negative 2 power equals x. So then if this is a negative exponent, I drop it to the denominator. And then x will be 1 over 36, okay? So we're rewriting in exponential form so that we can solve it, all right? This one, again, same idea as number 3, except now we have logs. We have a 1 for 1 property, okay? So since I have a log base 6 on this side and a log base 6 on this side, I can cancel both and then set these equal to each other, okay? And then solve for r. So if I solve for r, I can add 5r. Then I'll have negative r minus 9 equals negative 2. Add 9. Negative r equals 7. So r equals negative 7. Now, you always want to check that to make sure that it doesn't result in a negative value here, okay? And we did that on the homework that was due today, all right? So the last two, you can see, right, we have more than one log on either side, on each side. So here I have 2 logs, here I have 2 logs. So what you want to do is condense this using our properties, right? So like on number 2. So this is going to be log base 7 of x divided by 2, right? Because subtraction turns into division, equals log base 7 of 72. And then since I have now 1 log and 1 log, I'm going to use the same property as up above. And then I can do x over 2 equals 72. And then since I want to get x by itself, and I want to remove that 2, the opposite of division is multiplication. So therefore x is 144. Okay, so that's like part 6. And then part 7, you can see you have multiple logs here. So similar to what we've done before. Up above, we're going to condense. Addition turns into multiplication. Okay, so then I have log of 2x squared plus 6x. All right, when I distribute that. Then, since this doesn't have another log on the other side, I can't cancel logs. But if you remember up here, right, I can go to exponential form if I have 1 log. So if there's 1 log, you're going to go to exponential form. Okay, so then I'm going to do 2 to the 4th power equals x squared plus 6x. And therefore 2 to the 4th power means 2 times 2 times 9, so that's 16 equals x squared plus 6x. And then I have a quadratic, right? So I'm going to subtract 16. And then I'm going to factor, like we did on the homework. And I've got to, this is IM, so I've got to multiply to negative 16 and add to 6. So that would have to be x plus 8 and x minus 2. So therefore x plus 8 equals 0, so x is negative 8. And x minus 2 equals 0, so x is 2. Okay? Now, you should always check, especially if you have a negative answer, okay, like I said up here, okay? Here this is positive, so I know that's going to work out here. But anytime I have x's in what I'm taking the log of, I want to check this. So if I check x equals negative 8 in my equation, I'll have log base 2 of negative 8 plus log of 2 times negative 8 plus 6 equals 4. Well, right away, I'm taking the log of a negative number, so this answer does not work. But then if I do a check for x equals 2, log base 2 of 2, that's good, is my answer. The number I'm taking the log of is positive. Then log base 2 of 1 plus, 2 plus 6 equals 4. Well, that's 8, right? So log base 2 of 2 plus log base 2 of 8 equals 4. So these are both positive numbers, so that checks. So my only answer here is x equals 2. Okay? Hopefully that helps you. Okay? I will also post this review sheet, and you can refer to it to help you. Okay? If you have any questions, feel free to email me, and hope you are all doing well.